Greetings everyone. Today we're going to explore all the ways that we can write linear equations. If by chance you have the review worksheet available to you, this video is going to review all of those questions. If you're working with another person studying, an adult, a classmate, and you need to have a more collaborative conversation, you can use this video to support that. So in this unit, if I was to generalize the topics, you need to be able to write the equation of a line in translated and/or slope-intercept form, whether you're given a graph, information, 2 points, scenario, a parallel or a perpendicular line. And we also covered writing an inequality of a line given a graph or a scenario. All right, let's start off by writing the equation of a line given a graph. If I take a look at this graph, we need to remember the rules about vertical and horizontal lines. In this case, I have a vertical line. It goes through the x-axis at 6. So our equation is very literal, x-axis at 6. The slope is undefined. That was last unit as far as asking you for the slope. This unit, I just care about the equation of the line. If you're given a diagonal line, we need to pay attention to where it crosses specific points, and I need to use one of those to write my linear equation. If I so choose slope-intercept form, then I would have an equation of y equals negative 2x plus 2, because my slope is down 2, right 1, and I go through the y-axis at 2. So that's my m, my slope. That's my b. We don't need to write negative 2 over 1 though, because that's not simplified. We want just negative 2. If I so choose to do translated form, that means my slope is still negative 2, but I can fill in many different points here. So I could fill in the point right 1, remember the sign's opposite, and up or down 0. In that case, I don't even need the 0, so that would simplify down to negative 2x minus 1. I also could use the point, let's see, negative 2x. I could use this point here and say right 3 down 4. So I actually have 1, 2, 3, 4, 5, 6, 7 ways I could write that in translated form. Given information, let's write the equation of a line that goes through 4, negative 3, and has a slope of 1/2. So in this case, I'm going to choose translated form because I know my slope, my m. I'm going right 4, down 3. If I ask you to transform that into slope-intercept form, then I need to distribute, which would get me to 1/2 x minus 2. Bring down that minus 3. Combine like terms. 1/2 x minus 5. So pay attention to directions. Does it matter which way I ask you to write it, or am I specifically asking for slope-intercept form? Let's take a look at this example. If you're asked to write the equation of the line that goes through the point 2,5 and has a slope of 2. In this instance, you know your slope, or your m, is 2, and you know you have an x value of 2 and a y value of 5. If I start by writing my equation in translated form, which if you're not told otherwise, you can leave it in translated form, would be 2 parentheses x minus 2 with a plus 5 on the outside. If in the directions you are asked to use slope-intercept form, then you would continue by distributing the 2 to get 2x minus 4. You'd bring down the plus 5. Then you would combine those like terms and you'd have y equals 2x, a negative 4 plus 5 is a positive 1. So again, what do you ask for? What do you want to choose? Translated form versus slope-intercept form. Write the equation of a line given this information of 2 points. So I have an xy and an xy. So the first thing I need to do, I don't have the slope. I need to do some slope work. Slope is y minus y over x minus x, which comes from rise over run. So my first y value is 2. I'm going to subtract my second y value of negative 5. Watch those double negatives. My first x value, the pattern will be negative 5, subtract 2. Double negative becomes positive. Negative 5 minus 2 is negative 7. Do not leave it that way. Always simplify or reduce your fractions. So my m is equal to negative 1. Then I can choose translated or slope-intercept form. Typically, I would see translated form, so I'd see negative 1. And you could use either point. So I might see x plus 5 plus 2. That would be using the first point. Or I might see x minus 2 minus 5, which would be using the second point. Either of these are okay. I don't care which point you choose to use. Let's try that one again. If you haven't done this problem on the worksheet previously, my suggestion would be to pause this video, try it on your own, then rewatch it and see how you did. So I have an x comma y value and an x comma y value. I need to find my slope first. So 9 minus 9 over 5 minus negative 4. That gets me to 0 over 9, which is equal to 0. My slope is 0. Take a moment. What kind of line is that? Is that vertical or is that horizontal? That would be a horizontal line, which means a horizontal line, if I'm looking at a coordinate axis, goes through the y-axis. So a couple of ways to approach this. If you were to just approach it using translated form, you could use any point. But notice if you times by 0, all of that goes away and you end up with y equals 9. That's what I'm looking for right there, y equals 9. Remember the shortcut. If you have the same coordinate value for the y's, it's y equals that number. Also, if you get stuck, you could literally graph those points. If I go over 5 up 9, if I go left 4 up 9, take a look at that. That would go through 9 on the y-axis. So you could visually think about it and also still arrive to the same equation of a line. What if information is given to you in a scenario, in a word problem? In this case, I'm planning a trip to a ski resort, rent a snowboard and boots. It costs a fee of $30, and my pass is $10 an hour. So I want to write a linear equation that models that situation. The second question will wait a little bit to approach. So I know I'm going to have a y equals value. I need to explore maybe some kind of rate and a starting point, or if I don't have a starting point, then maybe I need a random point of data. So in this particular example, the rate is $10 an hour. I have a base fee of $30. Base fee means that's a good starting point. So I'm going to use slope-intercept form. So y equals, my rate is 10, and my starting value is 30. So this would be my linear equation. How much does it cost now to snowboard for 3 hours? So I have to decide, does this go in for x or y in my equation? Well, if it says $10 an hour, my rate is hours, I need to plug it in for x. So y equals 10 times 3 plus 30. 30 plus 30. I end up with 60, but I'm not done. 60 what? $60. Always label. There's labels in the question, there needs to be labels in the answer. And always self-evaluate. Does that make sense? Yeah, it makes sense. It's going to cost more if I'm snowboarding for 3 hours. It's more than the base fee of 30, and I'm adding on $10 3 times. So that makes sense. Let's talk about parallel and perpendicular. If I need to write a linear equation for a line that passes through 12, 2 and is parallel to the line of f of x equals 1/4 x plus 3. Let's underline the key information. I have a point I need to use, which is an x comma y. I have the word parallel, which means the slopes will be the same. And what do I need from that other line? Well, if I want the slopes to be the same, I want to use that slope value. So if I really break down my information here, I have a point of 12, 2, an x and a y, and I have a slope of 1/4. Now I'm just going to do what I did in the previous questions, write the equation of a line. Y equals slope. I'm going to use translated form, so a minus 12 and a plus 2. A little side note, if you're working with students in another class and if they're writing this a little different, they might write it like this. It's the same idea. They call it point slope form, but look, it's the same thing. They just kicked that 2 back over to the left side. We've been spending so much time isolating y that I wanted to keep having you isolate y. So we just kicked that 2 back over. That's the only difference between those. All right, let's try another one. Let's take a look at some key information. In this particular example, I want to write the linear equation of a line that goes through the point -5, -5. There's my x and y value. It's perpendicular to this line. So perpendicular means opposite reciprocal. So if you need to review that, make sure you study that in your notes. So in this line, what do I actually need? I need the slope. So my slope of that line is currently -1. So let's talk about the information I need to use. I need to use -5, -5 for my x and y value, my point. And I need the opposite reciprocal of -1. Well, if I flip, let me change that, I don't need that arrow there. Let's go this way. If I'm doing the opposite reciprocal, that means it becomes a positive. And 1/1, if I flip it, still 1. So my m is +1. So if I write my new equation of the line, I have y equals a slope, parentheses x plus 5, watch your signs, and a -5. Be very careful when your slopes are 1 and how that flips and what that looks like. Let's try one more. If I am asked to write the linear equation of the line that goes through -2, 0 and is perpendicular to that line. So key information. I have my point value. I'm looking for perpendicular, which means opposite reciprocal slope. And I have this line and I care about this number here. So if I want the opposite reciprocal of -4/1, that means it becomes positive, and that means it becomes 1/4. So the key information I need to use is -2, 0, and I want the slope of 1/4. Let's write our equation of our line. Y equals slope x plus 2. The end would be +0, so I don't really need that, okay? It's unnecessary, it's not going to change anything. So I would just leave it off, and that would be your final equation. All right, let's take a look at writing inequalities of a graph. So first of all, if you could fix a few things. This scale here, this should be a 6 because you'll notice everything else is counting by 2s. So watch your scale. And then I know it's hard to tell, but I'm going to have you add dots. And we're going to make those exact points. It's a little bit off. Know that on the test, it'll be obvious where your points are. Everything will be exact. But if you have a question about something like that, just make sure to ask. So to start off, think of it as an equation to get going, which means I need to deal with my slope first. What's my m? Notice your scale. You're rising 2 for each one. So 1, 2, 3, 4. I'm rising 4. I'm running 1, 2. So my slope is actually 2. So I start off a y. I know I have a slope of 2. And in this particular example, I could do slope-intercept form because I have a y-intercept of -2. So I'm dealing with the form y equals mx plus b there. But This is an inequality. Should there be a line under my inequality sign? And that answer is yes, because it's a solid line. And then I also need to determine if it's greater than or less than. In this example, I shaded above the line. Because I shaded above, it's going to be greater than. If I needed to check with a quick test point, 0, 0 is shaded. So if I was to plug that in, 0 greater than or equal to 2 times 0 minus 2, I would get 0 is greater than or equal to negative 2. That's good, that's true, that proves that I'm right. Now, if I wanted to do translated form, I'd use the same slope, I'd use the same inequality sign. The difference is what point I might use. So I'm going to set up a couple of options here. Let's say I wanted to use, let's use this point here. Then I'd have a minus 4 inside and a plus 6 outside. Let's say I wanted to use this point down here. That would mean I'd have a plus 2 and a minus 6. So key things, start with what you know, the slope, the intercept or point, then determine your inequality sign. All right, let's take a look at one more. In this particular case, the key information I need to start with is my slope. If I take a look, it looks like my slope is down 1, right 1, so that would mean it's definitely negative. But if I wanted to confirm by going between dots, if I was to take a look, down 1, 2, 3, 4, 5, and I'm going right 1, 2, 3, 4, 5. So that confirms that my slope is definitely negative 1. So to start off, I'm going to have a y, I'm going to have a slope of negative 1. In this particular example, I could use slope-intercept form because I have a y-intercept of positive 1. That's using slope-intercept form. But I have an inequality. So first, should it have a line underneath? No, it shouldn't because it's dashed. It's not or equals to. Then if I take a look, am I shading above or below the line? This would be considered below the line. So below typically goes with less than. So I have a less than symbol. Now if I wanted to do translated form, I have a few other options as well. Still less than, still a slope of negative 1, but I can choose any point along that line. So just for an example, let's say I was going to use this red dot there because it's nice and specific. I could say a plus 2 and a plus 3. Well, let's say I wanted to use this red dot below, that would be a minus 3 and a minus 2. Let's say I wanted to confirm using a test point just to make sure that I pointed my sign the right way. Well, if I look 0, 0, this dot is shaded. So I'm going to use 0, 0 as a test point. If I say 0 is less than negative 1 times 0 plus 1, 0 is less than 1, which is true. That's good. I was right in pointing to the left. All right, let's take a look at writing a linear inequality from a scenario. In this example, Sarah's selling bracelets and earrings because she needs to make money for summer vacation. The bracelets cost $2 and the earrings cost $3. She needs to make at least $60. Let's start by writing a linear inequality in slope-intercept form that shows the various options of what she can make. So to start off, I know my total is 60. I know I'm going to use the 2 and the 3. Because I don't specify which to make your X and Y, you can choose. So let's say I want to make bracelets X, and let's say I want to make earrings my Y value. I would label those in the problem. That way, if you need the information, you can look back later. Now, at least $60. Can she make $59? No. Can she make more than $60? Yes. So we want 60 to be the least she makes. She wants to make more than 60. And if she makes at least, meaning exactly 60, that's okay too. Now she's selling both types together, so that's where we have a plus sign there. Now I want this inequality to be in slope-intercept form, so I need to isolate the y. So let's subtract 2x to the other side first. And then I'm going to divide both sides by 3, which gets me to -2/3 x plus 20. So that's what I'm going to look for first, is that inequality. Let's read the rest of the question. If she sells 20 bracelets and 20 sets of earrings, will she make enough money? So if I plug in 20 for x and 20 for y, does she make enough? Now here you can choose if to plug it into the first equation or the second equation. Because I have this slope-intercept form and there's a fraction, to be totally honest, I kind of want to avoid that fraction. So I'm actually going to use the first equation here. So that means if I plug in 20 for x and 20 for y, do I end up with greater than or equal to 60? That's what I need to find out. So I would end up with 40 plus 60. And I'd end up with 100 greater than or equal to 60. Is that a true statement? Yes. So my question, will she make enough money? Yes, she will. Let's take a look and review some linear regression. In this particular table, anthropologists use this linear model to relate the femur length to height. This table shows the femur length of an individual with a partial skeleton when only the femur is found, and comparative to the height. So I have 1, 2, 3, 4, 5, 6, 7, 8 data points to choose from. I want to pick 2 points that are representative of the data. So I don't want to pick numbers right next to each other, and I don't want to pick any outliers. Well, if I take a look, as femur length decreases, height decreases. Nothing seems to be too out of place, except for, maybe this one seems a little bit off, because then it jumps back up to 68 and goes down. So maybe I want to avoid those two. But if I look, this is the highest overall, this first point, and this is the lowest overall for that last point. So they would be good, 2 good points to pick. So to start off, I am going to find the slope between these 2 lines, or 2 points, excuse me. So y minus y over x minus x. So I'm going to start off with a y value of 178.5, and I'm going to subtract 155 all over 50.1, subtract that 38. Now, you guys need to have your own calculator for the test. You can do this by hand, but it would sure be nice if you had a calculator. I'm going to do it by hand because I don't have one with me right now. If I was to subtract 155.0, double check my work here. Looks like 3, 2, I got 23.5 on top. And then if I do the bottom work, 50.1 minus 38.0, I'd get a 1. I need to carry this over. I get a 2 and a 1. So I got 12.1. Now we talked about how slope, you really don't want those crazy decimals. You typically want nice clean numbers. So in this case, I would actually have to times by 10 to get that to be. Now, on the test, it'll be obviously a clean number or obviously just a messy number. In this particular example, let's times both top and bottom by 10 and see if we can increase that to a nice clean whole number. So what that means is I'm literally timesing by 10. Here's why I chose that. I'm moving the decimal over 1. So I end up with 235 over 121. So look how clean and neat that worked out. So I like this number for my slope. Next, I need to write an equation. I can use either point that I originally used. I'm just going to go with the first one for the fact that it's the first one, no other reason. So I have y equals my slope of 235 over 121, followed by an x. My x value, I'm going to subtract 50.1, and I'm going to add 178.5. I know we have some decimals in there, but it's hard to avoid when those are given to me as points. Slope-intercept form doesn't make sense, so in this case I would just leave it in translated form. But I'm not done. I have got a second question here. It says if I find a femur length of 58 centimeters, how tall was the person? Well, femur is X values, height is Y. So that means I need to plug in 58 in for my X value. I need to use that equation that I was given. Okay, so in this case, you guys definitely need a calculator at this point. So please consider that when preparing for the test. So I'm going to have you calculate, but let's make some assumptions. 58's bigger than what I have on this table. So that means the height should be bigger than what I have on this table. My answer better be greater than 178. So calculate that out and label it as centimeters. I'm going to leave that up to you. All right, so this video covered all of the topics about writing linear equations over and over again. If you have any questions, make sure you ask. Take advantage of the Sabre Center. If you need to visit with me before or after school, let me know. But open to a lot of options in preparing and studying. So keep me updated, and until next time, have a good one.